Okay. At the top of this paper, please write. Listen, we're not talking about your grade right now, okay? Please write the acronym for sine, cosine, and tangent. And Bishop, just be ready to take it. The acronym for sine, cosine, and tangent, SOHCAHTOA. I asked you to do the first 4 problems. So 1, we had less time taking notes. 2, to refresh you on what you did on Friday. The quiz grades overall were very good. I need to get with a few people. I think you misunderstood one. There was one, and I went in and I gave full credit if you answered it in the wrong form, but your answer was right. One of the quiz questions was asking for the fraction, just the ratio. But for some reason, a few people didn't have a pretty ratio and it wanted it as a decimal. And then for some people, it wanted it as the fraction, which I don't like that. I wanted it the same question for everyone. So I went in for the people who had the decimal question, because if you entered the fraction, I gave you the full credit. Even though it marked it wrong, I gave you the credit. But overall, the quiz grades were very good. Those grades are already in the computer. If you were out Friday, you need to stay with me during Flex today to take it. We are going to finish up Trig this week. You will have a test this Friday over the Trig stuff, so the stuff from the quiz and what we do this week. Today and tomorrow is going to be one of your favorite lessons, because if you will listen and think and practice, it is easy. Okay? Looking at the first 4. Solve for the unknown variable, show your work, go to 2 decimal places. If you recall from last week, the first step in the process is labeling your triangle so that you know what trig function you're working with. You should have found this to be which one? Sine. Set up your trig function. That means trig, angle measure, equals fraction bar. Plug in the fraction based on the formula for sine. It's opposite over hypotenuse. Every single one of you should be writing that down. You cannot do that part in your head. And then the next step is cross multiplying the bottom of the fraction to the front of the trig expression. And sometimes you're done, sometimes you have to go further. In this case, we're done. We can go to our calculator. What mode does your calculator need to be in? It needs to be in degree mode. Look at the top of the home screen and you should see the word degree. If you don't, if you see radian, you need to change it. So we're going to type 15 sine 55. We're going to 2 decimal places, which means check the third number. Just the third number, nothing else. So the third number is 7. So the 8 becomes a, what? 9. So it's 12.29. Alright, let's go through these quickly because you were already supposed to do it. Recall from last week we said that if the hypotenuse is blank, it's which trig function? It's tangent. Trig function equals fraction bar, opposite over adjacent. When you typed this in, you should have come to 155.25. Yes?
No.
Okay, number 3. We've got hypotenuse, adjacent. What trig function? Cosine, angle measure, equals fraction bar. In this particular example, am I ready to go to my calculator? No. No, I can't go to my calculator yet, right? I need to move cosine 42 by division up underneath the 5. Then you can go to your calculator. You should have come to 6.73. Number 4, you should have used which trig function, y'all? On 4, cosine. Did you come to 9.93?
Yes, ma'am.
Okay. The next 4 questions are involving something new. Okay? And honestly, I can only ask like 4 questions on it because it's something that doesn't change. You can't make it progressively more challenging. It's a new concept. We're going to practice it 4 times and hopefully you remember it. Okay? Let's title it so that your attention is drawn to it. So if you come to a practice problem later, you maybe can find your work in here. We're going to write co-function. We're going to put it in a box. We are looking at co-function. I guess I should put an S there. Co-functions. Let's put an S because that sounds better. Co-function identities. What I mean by co-function is there is a relationship, a pattern between the sine of one angle and the cosine of another angle from the same triangle. There's a pattern that exists every time. So what I'm going to do is see if you recognize the pattern, and then we're going to practice it, okay? So look at this one. In triangle FGH, they tell us angles G and H are complementary. Okay, you've not seen this before. If I tell you 2 angles are complementary, what does that mean they do?
90 degrees.
They add to 90. If G and H add to 90 in triangle FGH, then which angle is the 90-degree angle? Let me ask it again. Yeah, so listen to my question. If G and H add to 90 in triangle FGH, then which letter represents the angle that is 90? It's the right triangle. It has to be F, right? Wrap your mind around it. Look, if G and H add to 90, can either of them be 90? No. So the only letter left would be F. I'm going to draw you a picture, but I'm trying to show you that here's another way for me to present a problem to you, and I've secretly just told you which letter is the right angle without flat out saying angle F is 90 degrees. I've secretly told you that if G and H add to 90, then by default, the letter I have not discussed would have to be the right angle. Okay? So this means G plus H equals 90, which means F is my 90-degree angle. So let's draw a picture. We're going to put F here. Doesn't matter where you put G and H. I'm just going to put them there and there. Now let's read it. It says, cosine of G is 4 over 7. This should be familiar from last week. They have just given you 2 sides of the triangle. How do you know what 2 sides they gave you? How do you know what 2 sides they gave you? Because it says cosine. Colt's here. What's the formula for cosine, y'all? What's the formula for cosine? So this is the adjacent and this is the hypotenuse. So go to G. Adjacent's 4. Hypotenuse is 7. Been sitting there. You can actually have the big desk if you want. Yeah, because yeah, you're good. The paper you need is right here. All right. So adjacent to G is 4 and the hypotenuse is 7. It says, what is sine of H? What's the formula for sine? Opposite over hypotenuse. So look at my picture. What is the trig ratio for opposite over hypotenuse in my picture? Still 4/7, right? So you might feel like you've done this wrong because you came to the answer, you came to the number that they gave you in the problem. But look, they said cosine of g is 4/7. We drew the picture. Then it says, so what's sine of h? Well, h is here. Sine means opposite over hypotenuse. So sine of h would be 4/7. Okay, let's go to this one. No, well, go to the next one. In triangle IJK, angle I is a right angle. Now this time they flat out told us, right? We have IJK, and angle I is the 90-degree angle. If sine of j is 5/13, what is the formula for sine? Yeah, you gotta quit blanking out because it's making my job difficult. What's the formula for sine? It's at the top of your paper. Okay, so opposite of j is what length? From the fraction that they just gave me. 5. And the hypotenuse is what? 13. Now it says, what is sine of k? That should say cosine of k. Yeah. Can y'all mark that out and write cosine k? What is the cosine of k? 5/13. Well, yeah, you have to do the Pythagorean here, but what I'm trying to teach you, I needed it to be the other trig function. All right, so what do you notice about the sine of one angle and the cosine of the other angle in the same picture? They're the exact same fraction. Are they the same formula? No. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So are the formulas the same? No. But if I'm looking at one triangle and I find the sine of one angle, then I go find the cosine of the other angle, I'm going to get the same fraction. And that's because, watch this. Watch where I highlight. Sine of g, no, let's see. What was it? Cosine. Cosine of g was 4/7, correct? Okay, now jump to h. And jump to the other trig function. Sine of h is 4/7. So, the whole purpose of these 4 questions is this vocab word right here, co-functions. You're learning that co-function, co meaning coexist, multiple, in this case we're talking about 2. We're learning that the sine of one angle is always the same answer as the cosine of the other angle. Now, why is that? Because it's right here. The 2 non-right angles are always what in a right triangle? They're always complementary. I'm going to say it again. The two acute angles in a right triangle are always complementary. Because of that, they are what's called co-function identities. So let's look at this one. In triangle LMN, angle L is the right angle. They tell us that tan of M is equal to 1. What must be true? Well, if tan of M, what's tan, what's the ratio for tan? Okay, so they're telling us tan of M is 1, right? That's what they said? Okay, and the formula for tangent is opposite over adjacent. Well, does it have to be 1/1? Not necessarily. It could be. Could it be 5/5?
Yeah.
Could it it be 10 over 10?
No.
Could it be pi over pi? So the idea is that the opposite and the adjacent have to be the same number, which means if you look right here, in that particular case, this means, I'm going to draw an arrow, this means the opposite has to equal the adjacent, which means it's an isosceles triangle. So if it's an isosceles triangle, in that particular case, the sine of any angle in there is going to equal the cosine of any angle, and that's because it was isosceles. All right, look at this one. In triangle PQR, they tell us R is the 90. What must be true? This right here is exactly what we just covered. The sine of one angle, tell me, okay, don't yell out the answer until I say, okay, what'd y'all get? Of the 4 choices, find the choice that says the sine of one angle equals the cosine of the other angle. Of those 4 choices, find the one choice that says that the sine of one angle is equal to the cosine of the other angle. Which one did you pick? C. It's not A, because A was both angle Q. All right, now right here underneath it, here's what I want you to put, because this is what the takeaway is. So, for example, ready? Sine of 20 degrees. I don't even have to draw the picture. Sine of 20 would be the exact same ugly decimal as the cosine. Now, 20 plus what equals 90? Of 70. Let's do another one. Cosine of 10 would be the same as what? Sine of 80. Let's do another one. Sine of 60, let's just keep them pretty, would be what? Cosine of 30. Where are we getting these numbers? You have to add to 90. That's how you get the other number. You're just saying 90 minus the one that they gave you, and you're switching to the other trig function. Notice which one's not used at all. Which trig function is not mentioned? Tangent. So that's the takeaway. So if I ever gave you a question that said, what trig function is equal to sine 20, and I didn't give you a picture or anything else, I'm looking for you to say cosine 70. Okay? All right. Come down here to the bottom. Write an equation that you could use to solve for x. And now I specifically said, don't use sine. What equation could I use to solve for x here? What? Pythagorean theorem. Let's refresh you on the Pythagorean theorem because it's been a day. Draw an arrow to the hypotenuse just so that you remember where. Draw an arrow to the hypotenuse so that you remember where that's going to go into the Pythagorean theorem. That goes in the c squared part, right? A squared plus b squared equals c squared. I wish y'all would quit talking. Being rude. So 4 squared plus x squared equals 6 squared. Are you writing these down?
Yeah, I'm on bed.
36 minus 16 is what? 20, and we're just going to leave it as the square root of 20. We're not going to break it down or anything, guys. All right, come down here. What's another way you could solve for x? All right, which one? You could use tangent. We're not actually solving it. We're just going to set it up. If we use tan, what would our ratio be? Okay. What's another way we could solve it? Okay. If we use sine, what's our trig ratio? X over 6. What's another way? If we use cosine, what's our trig ratio? Would cosine work? I'm going to write it, and then I'm going to put a x through it to show that cosine would not be helpful here, right? If I was trying to solve for x. The reason we did that is because we're getting to the point where I'm going to throw a triangle at you, and you have the freedom of choice of which one you want to use to solve. So you have to know when is one of them not helpful. That's the purpose of this question, is to recognize, oh, if I use cosine, I set it up correctly, now I don't have an x in there at all, so I can't solve for x if I don't have x, right? Please go to the back and do it right now.
Whoa.
Go to the back and do it right now. This should not take 10 minutes. If you'll keep your mouth shut and work diligently, because we have 2 more papers after this. The first paper takes like 10 minutes. So you're going to the back. It might be helpful to rewrite your trig formulas on the back. Pay attention to the directions. You are going to 2 decimal places. So you're on the back. The directions say solve for the unknown sides. This is where, remember, you label your triangle, and then you set up your trig ratio, and then you cross multiply the bottom of the fraction over, and sometimes you're ready to go to the calculator. Sometimes you have to divide.